Uh, is something broken? Did I click on a new nugget and I'm sitting here? This isn't a title slide. There's no learning goal. There's no witty story from Jeremy to start it all off. That's right. We're crazy here at CBT Nuggets. We're going to start Nuggets a little differently this time. We're going to start right here where we left off in the last nugget, which is OSPF. Yes, in the last nugget, I tried to cram it all together. Routing protocols and OSPF all in one manageable sitting. It's just not possible. Don't do it. We're starting OSPF a little different this time. Now, the fact that we're even talking about OSPF is a radical change from previous editions of CCNA. If you've heard some, if you've been in the CCNA realm, you know that we always learn RIP first. And I've been teaching it that way for so long, it almost escaped me how silly. It's like now that I look back, I'm like, does anyone really realize how irrelevant RIP is to the world? But my father had to learn it, and his father had to learn it, so you'll learn it too. Well, not anymore. RIP is done. Rest in peace. That just came to me. Rest in peace, RIP. You are now replaced by OSPF. Now, does that mean RIP as a protocol is gone? No, it's still out there. The beauty and the reason we've learned it for so long is it is the simplest of all routing protocols. But the fact is, you walk out of your door right now and walk in any network in the world, and chances are very good it's not going to be running RIP. If it is, email me. I want to hear from you. but most of the networks of the world run OSPF, the most popular routing protocol in the world. Now, the reason it was in CCNA is because this was the simplest, but somebody sat down, sharpened their pen, and said, you know what? OSPF is just a little bit more. I mean, it's not that much more to understand the foundations. Now, keep in mind, OSPF. Think of we got a little beach here, a little beach umbrella, some people on a lawn chair sitting, the waves coming in, and you got all this sand on the beach, right? And then sitting on that sand is a bucket. Looks like a large bucket in perspective of that person, but it's not. It's full of sand because all this sand represents OSPF in all its glory, and you're going to learn what's in that bucket. You're not going to learn all of it, but you will learn enough that you'll be proficient with OSPF. You'll be able to recognize the configuration. You'll be able to set it up yourself and get it running. You'll be able to hold your own with OSPF. That's what my goal is. Before we dive into how to get OSPF working, I want to take a step back. Big picture, what's OSPF do again? It lets our routers talk about what they think is most interesting. Router 1 is going to talk to Router 2 about everything it knows, and it knows things that it's plugged into. It knows about the 192.168.1 network. Why? Because you as an administrator configured it in that network. So it knows, hey, I'm plugged in there, and I know I'm plugged into the 192.168.2.0 network. Why? Because you configured it to know that. So it then talks to Router 2 and says, hey, I know about 2.0 and 1.0, and Router 2 says, that's great, I knew about 2.0. This is our common ground. This is where we talk about. So, yeah, that's great. I'll just, FYI, whatever. But I didn't know about 192.168.1.0. Ooh, that's news. I'm adding that to my routing table, and I'm going to use you, Router 1. I'm now talking as Router 2, playing the role. I'm going to use you, Router 1, as my next hop to get there because you told me about it, and that just makes sense. And Router 2 says, and by the way, there might be something you want to know about. I know about 192.168.3.0. I just got out of a conversation with my kids. I love the suspense that kids have when you talk to them, and I'm like, guess what? Guess what? And they're like, what? We're going to go to Dairy Queen. And they're like, oh, Dairy Queen ice cream. Yay. Routers go through that all the time. He's like, hey, I know about 192.168.3.0. And Router 1's like, yeah, I never knew about that. I'm adding it to my routing table. And now I have a way to get there. Which way? You, Router 2, because you told me about it. So that's how they inform each other. Now let's dig a little bit deeper. That's routing protocols, and all routing protocols do that. That's their goal. How does OSPF do it that's a little different than, say, RIP? Well, OSPF uses something known as a hello packet. Oh, so different than RIP. See, RIP never really forms a relationship. It's just a bunch of passerbys screaming information out. If these guys are running RIP, Router 1 and Router 2 are just yelling. They don't really care who gets it. They're just sending a big broadcast or multicast message saying, hey, everybody, I know about this, this, and this, and this. There's no acknowledgement that anybody got that. They don't really follow up with that to make sure the information was received in any way. They just broadcast it out and hope it gets there. Now, OSPF is much more methodical than that. OSPF says, from router 1's perspective, the very, very first thing he sends out is a hello packet. And they should have called it a hello package, because it really contains all kinds of interesting information about router 1. It contains, for instance, a series of timers. Like router 1, inside of this hello package, when router 2 opens it up, he's going to see a little piece of paper that says, hey, you know what? I say hello once every 10 seconds, and I have a dead timer of 40 seconds. What's that mean to router 2? That means I can expect that router 1 is going to be like, hey, man, every 10 seconds, just to make sure that I'm online, that I'm available, and I can also hear from router 1 that he's available once every 10 seconds. Same thing if he doesn't hear from somebody, if he doesn't hear from a friend, a neighbor in 40 seconds, then he's going to consider that neighbor dead. So router 2 now knows, okay, when speaking to router 1, I know if he doesn't hear from me in 40 seconds, he's going to consider me offline, and he's going to mark all of my networks unreachable. Now, the reason that this is a big deal is OSPF is very picky about its relationships. If the timers don't match, if router 1 is saying hello once every 10 seconds and router 2 is like, I'm a speedy router, I say hello once every second, hello, 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 hello. If he's that way, they're not going to form a neighbor relationships. Timers must match. The area that they're configured in must match. Now you might say, well, what's an area? That's part of the buckets of the sand of the seashore that we're not really going to talk too much about, but let me give you the high-level view. OSPF allows you to break your network up into kind of groups of networks. So here's the idea, right? All networks start really small. Maybe it's 2 offices. Over here is an office in Minnesota or Michigan, because I don't know the abbreviation for Minnesota. And then over here is an office in Texas, right? That's just where the business begins. And then it kind of grows from there. It grows, you add more offices, and you get to 10, 20, 30, 40, 50, 60 offices. Is starting to get a little chaotic, right? You've got all of these different routers that are connected together, and your routing table is getting bigger and bigger and bigger and bigger and bigger. And here's the fact. The bigger your routing table, the slower your router. So our goal as a network administrator is to say, I want to keep my routing table small, and areas is what help us do that. See, as I grow this, I eventually can say, okay, I'm going to break this whole group of routers into an area, and we'll call it Area 0. Now, Area 0 happens to be very special. It's the very first area that you create with OSPF. As a matter of fact, you can't run OSPF. You can't get OSPF working without designating an area. And for what we're going to talk about, everything will be in Area 0. Now, how big can Area 0 grow? However big you want it to. 50 routers, 100 routers, 1,000 routers? Sure. You can do that, but as that area grows bigger and bigger and bigger, eventually you're going to reach a point where you're like, it's too big. Our routers are running out of memory. They're slowing down. There's too many changes. Like a network goes down, and everybody's like, oh, I have to know about that. And all these updates flood my network. You reach a point where it just gets too big. Now, I will say big in terms of today, like 2013, is much different than big as it was in 2005 and big in 1993. And I mean, big, that term changes because our routers are beefier. They got more memory, more processor and all that. But eventually, you're going, what's an area? So an area is where you say, okay, at this office, I want to add a dividing line. I want to break this into Area 1. And now have a whole section of routers down here. Okay, you say. No, over here is Area 2. Let's add a couple. Why not while we're at it? Area 2. And here's a bunch of routers. Okay, what does that mean? What does that do? Areas, and this is a huge, huge concept. Hang with me. Areas represent a point of summarization. It's a point where you're able to summarize entries in your routing table down to a bigger network. Let me give you an example. Let's say up here I have, sometimes we draw these pictures of routers connected to routers, and you lose kind of the perspective. Think of each one of those little circles as an office. Like this is the Texas office, right? And over here is 10.1. 10.1.0/24, right? We got that network. And then over here is the Michigan office, and they've got 10.1.2.0/24. And then over here is the California office, and they've got 10.1.3.0/24. Are you seeing the theme? Right? Each one of these offices, this one might be 4.0, this one might be 5.0. The point is they all start with 10.1. So when we hit this area boundary, we now have a choice. Do we advertise all of those networks to where down here this router now knows, okay, 10.1.1.0 is up here, and 10.1.2 and 10.1.3, and I've got all these entries in my routing table, and my router's running slow because I have all this. Do we do that, or do we make a move? I would say we make a move. And we call that summarization, to where we take all those 10.1 networks and we say, instead of taking all the individual networks and advertising them down here, let's just do this. Let's just say I've got 10.1.0.0/16. Can he do that? Yep, we can do that. I'm a little weird today. I'm in one of those weird moods. So what that does is now suppress all of these individual updates. So now this router, in his routing, I mean, I drew 5, but imagine that was 50 or 500 routers. Let's go crazy, right? This guy, instead of having 500 routes, well, I guess we can't really get 500 routes out of that. Let's just say 200. How's that? Instead of having 200 routes in his routing table, he's going to have 1. He's going to know 10.1.anything/16, right? That means these two are the significant digits. 10.1.anything is up there, right? And now I've suppressed all of those more specific things. Number one, 2 things it does. Number one, makes our routing table much smaller, meaning our routers become much faster, much more efficient at what they do. Number 2 is it hides problems. See, here's the deal with OSPF. Everything in an area has to know what each other is doing. Like, if a network goes down over here, everybody in that area has to know about it. And it comes up, okay, everybody in the area has to know about it. It's the rule of OSPF. Everybody in an area must be synchronized. Like, they all know the same stuff. Well, that's a problem when we start spanning. This is our WAN connection from the United States over to India. Right? We have tech support offices in India, and we have this WAN link going over that. I don't want to flood that WAN link because it's slow with unnecessary information. So let's summarize. So when this network goes down, everybody knows about it up to here. So what does that mean? Do they not know that the 10.1.1 network is down? That's correct. They don't. They don't know it's down at all, and that's okay, because when they start sending information, it's going to go to right here, this router, and he's going to be like, oh, sorry, man, it's down. Drop all the packets, and so communication won't happen, and that's okay. We want to be able to hide. I mean, think about it. Are there like, did a network on the internet just go down right now? Yes. Did it come up right now? Yes. There are thousands and thousands of networks on the internet going down and going up every minute that we sit here and talk. We don't have to know about it. Our routers don't have to know about it. They just send it as far as it can get, and then it's like, oh, sorry, Microsoft.com is down, if that were to happen. So that's what an area is. But we're not going to talk about that, right? Areas and summarization and that configuration, that's what you do when you go beyond this sand bucket of OSPF. But the key is that area has to match. These guys have to be, I have to be, let's say, in area 0 on both of these routers, or else we won't form neighbor relationship. We have to have matched authentication. Like, if I have a passcode, like, I will only be your OSPF neighbor if you have the key Cisco. Right? And both of these have the same key. That has to match between the two. You can define a password. That way you don't have evil routers coming in, or computers pretending to be routers. They have those coming in and trying to form a neighbor relationship with you. And lastly, they have to have the same subnet mask. You can't have, /24 here, and maybe he's got a /16 or something over here. They're going to be like, whoa, we're not going to do that. We're not going to form neighbors. Now, if all of these things match up, then the hello is accepted on both sides, and they will become a full neighbor relationship, meaning they will start exchanging routes. Okay, so let's take that and now go into how to get OSPF working. Just starting off with a very basic scenario. We've got two routers, right? Each one is connected to a network that the other doesn't know about, so we're not going to be able to reach it. Like router 1 over here is not going to be able to reach router 2's 192.168.3 network because we have nothing in place to allow that. Let's prove that. I'm going to go to GNS3. Let's just right-click on router 1 and open a console connection to it. And so I've got router 1. Let's first off get our bearings. Here, I'll see if I can squeeze this over here. Let's get our bearings. Always show IP interface brief. My favorite command to just say, okay, what's what? And I can see right here I've got a serial connection, 192.168.2.1, lines up with what I see there on my network diagram. I have 192.168.1.1, which is the LAN network over here, and that all looks good. Let's do a show IP route. And I can see that this router knows about only connected routes. It knows it's plugged into 192.168.1.0 because I configured an IP address in that network. Same thing with 2.0. I've got an IP address in that network. So it's all looking good. And I can absolutely guarantee that if I type in ping 192.168.3.1, which is the LAN interface of router 2 over here, we're going to fail. And we can guarantee that because when we look at the routing table, if we're trying to reach anything that's not shown here, the router's just going to say, I have no idea what you're doing. So, last nugget, no, 2 nuggets ago, we got static routing to get this setup going. I'm going to go into global config, and let's do, first off, turning on OSPF. The command is router, and then the protocol you want to run. Now, I mentioned, remember the jelly bean slide, we had BGP, EIGRP, ISIs. I mean, all these different protocols that are out there. Some that we didn't even talk about, but they're out there, other routing protocols. We just need to pick the one that we want. In this case, we are using OSPF. So I'll fill that in and hit the question mark. And now it asks me for a big question. What is your process ID? You ever gone in Windows? Let me bring something up. Tell me if this looks familiar to you. Okay. Isn't this machine awesome? It's got like 8 processors. It's amazing. I didn't do that just to show you this machine. I wanted to show you this process tab. You ever gone in here? You ever gotten into Windows where things go bad? I mean, you're sitting. Nothing's gone bad in Windows, right? No. But you're in here. You've got whatever running. Dynamips is freezing or whatever. Something goes bad, and you're trying to kill a process. And have you ever gotten to a point in Windows where it won't die? You ever get in there? One of the things that you can do, see, this isn't a Windows course, but you can actually, I'm going to pull up Google. And obviously, I had recently gone through that experience because Google Chrome did not shut down correctly. So I'm going to do, what is it, task kill. Right? That's the command. Yeah. So this is a command. If you didn't know about this command, if you're in Windows, you live by this command because things break all the time. Task kill is like I'm going to kill a process, absolutely dead. I'm cutting it off. You're probably going to get some file corruption, but that's all good because that's normal in Windows. And we're going to make your computer stable again, right? So task kill requires that you identify a process by its process ID. And you can actually go in Task Manager. Let's see, where is it? Properties. There's a way. Now, of course, now I'm not going to view. Oh, wait, select columns. There it is. Select columns and process ID. Voila. Right there. This column, PID, is what you need for task kill. Like, oh man, mom. Mom is totally acting up, and we got to kill her. This is just not good. But anyway, we've got to kill the mom process. I need 3828 and I'm good. So you're going, okay, that's kind of cool. So I would go to a command prompt, typing task kill mom. I don't know what mom is, so I don't want to kill her. But that's what this is. A process ID just identifies the OSPF process to the router. You might say, well, what number should I use? Yeah. Whatever you want to use. But you got to remember it. You got to remember it. Does it have to be the same on all the routers in your network? No, because, I mean, just like if I went to another computer in my house, I would see that there's other, maybe mom or DWM is running with a different process ID on a different computer, right? So process ID doesn't really matter. However, you have to remember what it is. So the reason you have to remember is because you'll constantly be typing it in to go into this configuration mode. So let me just tell you this. Use one. That's it. And I know this section right here, this little process ID, just in the past has generated so many questions that it's just. I'm telling you, just use one. I know questions like, well, can I have multiple OSPF processes? Yes, you can. No, you don't want to. Can I use process ID 1 and process ID 50 on another router? Yes, you can. No, you don't want to. Why? Because then you have to remember, well, this one's 1, this one's 50, that one's 392. Just use one. Okay, so we're in OSPF, and actually we've done step 1. We've turned it on. OSPF, it's like the little light switch on our router. There's our light switch. We just went from off to on, right? So it's now running, but it's not doing anything because we haven't told it what interfaces to use. Okay, big command here. OSPF works based on this command called network. The network command, I would say this is got to be one of the most confusing commands in all Cisco, and they're actually making it go away. As we move into IPv6, the network command is actually gone because Cisco knows it's crazy. It's a crazy command. The reason why is it's one command that does two very similar yet very different things. When I type in network, I'm number one identifying. You might write this down. If you're taking notes, write this down. Embed this in your mind. It identifies. Hang on. Beauty of a pause button, right? It identifies what interfaces to send hello packets on. I know if you're a grammatical person, you're like, you can't end in a preposition, but I just did because that's the only good way to say that. It identifies what interfaces to send hello packets on. So when I type in network, so here, let me show you the command, right? I type in network 192.168.2.0. Right? Now there's more to this command, but let's just start there and hit the enter key. Now it's going to say, wait, there's more to this command, and we'll talk about that in a second. But when I type in network 192.168.2.0, it says, okay, let's see what interfaces do I have in the 192.168.2.0 networks, and it's going to go, nope, not that one. That's one, 192.168.2.1. That's in the 192.168.2.1, 2.0 network. So I'm going to start sending hello messages on this interfaces. Why? Because it wants to form a neighbor. It wants to find friends to exchange routes with. So we're telling it, I want you to send hello messages out there. So when I type this command in, it's going to start sending hellos on there. Is it going to send hellos out here? No, it's not, because that's not the 192.168.2 network, right? Okay, so that's the first big thing it does. Second thing it does, it identifies what networks to advertise. So what we're doing when we type in network 192.168.2.0 is it says, I'm going to, number one, form neighbor relationships out that interface. Number two, I'm going to tell people about the 192.168.2 network. Right? Because maybe I don't want to tell people about this network. Maybe this is a secret ninja network where we have top secret Apple development on the iPhone 9 or something like that. It's we don't want people to know about that network. Then I wouldn't type in the network advertisement, because that is what tells the router to advertise that network. So now let me fill this in here. Let's say I type in this command, network 192.168.2.0, and hit the enter key. What have I done? This router now is going to try and form a neighbor relationship on that interface. And as long as router 2 is doing the same thing, as long as I've typed that same command in router 2, they're both going to be like, hey, man, it's good to meet you. And as long as all these things are up to par, which we're going to talk about those in just a second, as long as they're up to snuff and they're all matching, they're going to be like, let's be neighbors. And then router 1's going to say, okay, I got some really good information for you, router 2. I know about the 192.168.2.0 network. That's it. Router 2 looks and goes, that was not interesting at all, because I'm connected to that network. I already knew about that network. You are worthless to me, router 1. It doesn't really say that, but it kind of feels that way, because router 1's not giving it any information beyond that. Now, so what do we have to type in to let router 1 tell router 2 something it didn't know about? Come on, take a guess. Come on. We would type in network. Well, in addition, now it's going to give me an incomplete command, right? Because there's more to this, but let's just go with it. So I would also have to type in network 192.168.1.0. Hit the enter key. Okay, now again, filling in the end of it. So let's just focus on the base command first. If I type in that, now it's going to, number one, send hellos out that interface as well as the 192.168.2 because you have I mean they kind of go together, right? It's not like you just type one. So I'm gonna type in send hello messages out the 192.168.1.0 interface, and I'm gonna start advertising that network to other routers as well. Now router 2 is like, wow, you just became a lot more interesting to me, router 1. You're telling me about something I didn't know about, 192.168.1.0. Now, a question you might have, you're like, okay, well, does he have to send hellos out that interface? I mean, does he really have to? Well, not really. I mean, it's just kind of pointless hellos. He's like, hello. I mean, think of it like, one of those weird movies. You walk in the room, hello, 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 anybody here? But without the guy with the knife jumping out of the from behind the door. That's what this guy's doing. He's sending empty hellos to an empty LAN. Now, is that a waste? Yes. I would say on the least amount of consequence, it's a waste of bandwidth, a waste of resources. Number 2, is that a security hazard? Yes, it is. The reason why is he's saying hello out to a user community. If you've got a user, how many of you know you can't trust your users? Absolutely a fact. That smiling guy in the cubicle, he's trying to destroy you. He's trying to hack your network because if he starts seeing hellos coming in from OSPF, he's going to try and sabotage your network by becoming an imposter, acting like an OSPF router and forming a neighbor relationship with you. Now, you might say, well, why would somebody want to do that? Well, I would say on the least amount of damage, they can really mess up your network. They can go in there and they could start advertising routes that don't really exist. They could just sabotage your routing table. And that's number one, you don't want that. But I'm telling you, if somebody's trying to do that, what they're probably trying to do is set off some kind of man-in-the-middle attack. You ever heard of that? Man in the middle is where you try to inject yourself, meaning a computer or some device in the middle, to where you make this router believe you're a good exit point to the internet. And then you do some wizardry behind the scenes to really say, oh, well, actually, I can get you to the internet. So essentially, all of the routing goes through your computer. And, maybe it's out a Wi-Fi connection. There's all kinds of tricks you can play to do the man in the middle attack. But you get it to where it's going. But now you are in the middle so that you can start opening a tool like Wireshark and capturing all of the data. So now you can start seeing what people are doing on the network. You can start gathering information. It's easy to do with Wireshark. Start reassembling, Excel files that people were working on, spreadsheets, emails that were being sent, voice over IP conversations that were being had. You can actually capture those if you're in the middle and put them all back together. And now you've got scary data that you can walk away with. So you don't want that. So you might say, okay, well, what if I want to advertise that network? Now, I want to advertise that to this router, but I don't want to send hello messages there because I know I won't ever have a neighbor. Is there a way to split this network command and say, well, do number 2, this is good, don't do number 1. I don't want that. Yes, there is. That is actually known as the passive interface command. Check it out. I'm going to go back on router 1 and I'm going to type in. Notice I'm under OSPF configuration mode. I'm under this router config mode. I can type in passive interface and say, well, I want to be a little passive on, we'll say fast Ethernet. I don't remember what it was, 0/0, whatever. I'm not going to type it in because I don't remember what it was. And if I do the wrong one, then it's not going to send hellos out this interface and no neighbor relationships will form. So passive interface, I know it's almost like we're at the foundations of OSPF. Here's how it works, and I'm already introducing the passive interface. The reason why is it's that important. You want to use the passive. Matter of fact, tell you what, a lot of people do is they'll actually type in passive interface, and then let me show you the question mark again. Passive interface default, which says turn off all routing updates, turn off all hello messages on all interfaces. Type that in there, just like that. No more hello messages anywhere. You're like, well, that kind of defeats the point, right? Well, yes, because now you can go in and do no passive interface, and then I can do, well, I got to figure out my interfaces. Show IP interface brief, right? I can do no passive interface and do serial 0/0. So now it's saying, okay, everything's passing. Nothing is sending a hello messages unless you as an admin go in there. That's a really good practice. What I just did right there, really good security practice to make sure you're not sending hello messages where they don't belong. Remember, anywhere you send a hello, that's where a potential neighbor relationship can form. Okay. Let's get back. We've got to get back to configure. Let me just clear this off for a second. All right, there we go. That's a little better. Let's get back to the core of everything. We are in the middle of telling it what interfaces to use, right? And we kept seeing that incomplete command when I was typing it in. So we need to say router 1, use these two interfaces for OSPF. So I'm back in. I'm still under the here. Let me exit out because I cleared the screen. So router OSPF 1. I'm back into the router configuration mode. I'm going to type in network 192.168.2.0. But you remember we kept getting this incomplete command. What's it looking for? Space question mark. Let's find out. It says enter the wildcard bits. Okay, what's a wildcard bit? Well, let me first say we will unpack wildcard bits fully when we get into access lists. That's a big part of access lists, understanding it in its entirety. For now, I'm going to give you enough about wildcard bits to configure OSPF. Now, wildcard bits, think of these as identifiers. Right? We're going to try and identify in this IP address that we typed in, what should the router really care about? Here's what I mean. First off, wildcard bits are completely opposite of the subnet mask. So let's just write it up here. I'm going to type in network 192.168.2.0. Now let me give you a sample wildcard mask that we would use for this, and then I'll describe what it means. I'm going to do 0.0.0.255. Now, I know, it's wild, right? That's why they gave it the name. No one really knows why Cisco decided to do it this way, but they did. What it is completely opposite of the subnet mask. I mean, when you think about a subnet mask for 192.168.2.0, you're typically thinking of Class E, 255.255.255.0, right? Well, looking at that wildcard mask, it's exactly the opposite. And here's what it means. Just, again, high-level view right now. Wherever you see a 0, line it up to the IP address, because that's something that the router is saying, look at this. So let me draw the arrow there. Right there. The router is thinking, I'm getting used to this pause thing. Look at this. So 192 is significant to me. So I am going to identify interfaces by if they start with 192. That's key. I'm going to start sending hello packets on them. If they start with 192, I'm going to start advertising those networks, right? But wait, there's more. Wait, no cost to you. There's more. 168. That's the second octet. It's saying, look at this. So look at this router. When you're trying to identify, only turn on OSPF. Let me just go back to this. And when I say turn on, it means these two things. Only turn on OSPF on interfaces that start with 192.168. And then we look at the third octet, .2. Right? Look at this. Look at the 2. 192.168.2 is significant. Now, the 255 means I don't care. Period. I don't care what is in that last octet. Because, I mean, what really is happening when I type this command is the router is going to look at all of its interfaces. Let me get back here. I'm going to do a show IP interface brief. So when I type in network 192.168.2.0 and I type in 0.0.0.255, what the router is going to do is it's going to say, okay, let me look. Do I have any interfaces that start with 192? Yes, I do. Do I have interfaces that have 168? Because again, it's a look at this. Yes, I do. I actually have 2 of them. Do I have any interfaces that have 192.168.2? Because again, it's a look at this. Look at this third octet right here. And it's going to say, oh, yes, I do. This one qualifies. Now, this last octet, it's going to say, okay, .0, and it's going, whoa, that's .1. But wait a sec. You know what? I don't care. I don't care what IP address is in that last octet. I just want to identify any interface that starts with 192.168.2, right? So that is how the wildcard mask works. So let's do a little more example. Let's say I wanted to turn on OSPF for both of these interfaces at the same time, right? Here's something I could type. I could type in network 192.168.0.0 with a wildcard mask. Come on, think about it. Can you guess it? 0.0.255.255. That would be a way of turning on OSPF on both of these interfaces at the same time. Why? Because This one says, look at this. Look at the 192. Turn on OSPF on any interface that starts with 192. Oh, look at this. Second octet, 168. That is significant. Look at any interface that's starting with 192.168 for OSPF. And then it looks at these last two octets and it says, I don't care, I don't care. I don't care that this is a 1 and this is a 2. That doesn't matter to me. That's fine. I don't care that this has a .1 and this has a .1 in the fourth octet right here. I don't care because they start with 192.168 something. I'm going to turn on OSPF on them. Okay. Now, okay, let me go one step further. What if I wanted to turn on OSPF on every interface on my router that I have right now and any interface I add in the future? Come on, pause it right now. Think of it. Think of it. And I know you can. Think of it. Okay, unpause. Network 0000 with what wildcard mask? 255, 255, 255, 255. Done. It would work because that says turn on OSPF on I don't care, I don't care, I don't care, I don't anything now or in the future. Now you might say, well, that seems easy. Why don't we do that? Not good. Cisco says don't do it because there's a lot of times you're configuring your router and you're adding an interface here, deleting it there, and if you accidentally add an interface, it's automatically whisked into OSPF before you're even ready for that interface to be active. You don't want to do that. Matter of fact, you might say, well, what is Cisco's best practice? It's none of these. Seriously, none of these. What Cisco actually says to do is use a network of, do a show IP interface brief right here and say network 192.168.1.1 with what wildcard mask? 0.0.0.0. Network 192.168.2.1 with what wildcard mask? 2.1. 0.0, same thing, 0.0.0.0. What that does is it's like a sniper rifle with turning on OSPF. You're like, exactly this interface, an interface that has 192.168.1.1 as its IP address, exactly that interface, turn on OSPF. Right? That's the scoop. I mean, that's their best practice. Why is that the best practice? It's a lot more typing. It's a lot more, like, well, this is easy. Beware of easy things in the Cisco world because it's too far reaching. It's too automagic. We want to make sure that we know exactly where OSPF is running. So we literally type in a network command for every single interface and it starts advertising it. Now, another big misunderstanding of the network command. I remember when I first learned, I still remember this. When I first learned the network command, I was like, okay, so does this actually affect, like what is advertised? Like when I type in 192.168.0.0, is this guy going to say, I know about the 192.168.0.0 network? No, it's not. This is simply an identifier. Just like when I type in this, it's not going to say, I know about the 192.168.1.1 network. What happens when I type in this network command is the router goes and says, oh, look, I have that interface. It's in that network. Or I guess I'm based on the command I type below, I have that interface. So it says, okay, well, let me look at that interface's configuration. I'll do a show run interface serial 0/0, and it says, oh, well, it looks like this interface has the configuration 192.168.2.1 with this subnet mask. So it looks and it goes, oh, okay, so it's really connected to the 192.168.2.0 network. The router's smart enough to put all the pieces together. This network command does not impact the actual network that is being advertised. Now, it could just happen to line up. For example, if I type in this command right here, network 192.168.2.0, that does happen to be the network that is advertised over to router 2, but that's just happenstance. All of these every single one of these commands would work. This would make OSPF work. This would, these would. They all do the same thing, and all their goal is to identify. Think of these routers as standing and looking at its interface like a lineup of people, and it's about ready to play dodgeball, right? And it's like, I want you, and I want you, and I want you on my team, right? And the little interfaces walk forward, and they're like, yes. And he goes, okay, now who are you? And he's like, oh, my name is 192.168.2, right? So the network command just picks the people for dodgeball. It picks the interfaces for dodgeball. It does not actually dictate that this is exactly what is being advertised. Okay, good. Now, there's one more piece. I told you, it's the biggest command, most important command in everything that we're doing here. One more piece to this network command. right? And notice I hit the enter key. It's still like, okay, you got the wildcard mask, but it's still an incomplete command. Like there's more to this command than what you've typed in. So I go, okay, well, what else you want? And it say, oh, you need to tell me what area this network is in. Now, this is that bucket of sand I was talking about a moment ago. We're just going to configure everything in the backbone area, the very first area we create, which is always area 0. Okay. Now we hit the enter key and we get nothing. Nothing is always good in Cisco. That means it took the command. It's now working in that configuration. So I can say, okay, you've identified. Well, hey, let's do this. I'm going to say no network. I'm going to remove that command, and I'm going to use Cisco's best practice. Let's do 2.1, right, with a wildcard mask of 0.0.0.0. Identify specifically that WAN interface to use over to the other office, and then let's hit the up arrow and identify 1.1. The LAN interface to use up here. So we are, again, remember the two things. We are now sending hellos out these interfaces, and we are identifying both of these as networks to advertise to our friends. Now, I said sending hellos out both of these interfaces, although it's not happening here because we used, remember, that passive interface default command, and that's still in there. It's still taking effect, and that's fine. We don't have any neighbors outside of that interface. Okay, so now we can come over to router 2. So router 2, right there. Bring him into the picture. Let's get a quick orientation of router 2. We'll go much faster now without all the descriptions. So we've got 192.168.3.1, looks good. That's the LAN interface, looking at the diagram. 192.168.2.2, that's the WAN interface. Let's just make sure we can ping 192.168.2.1, just kind of getting some troubleshooting out of the way before we get there. And then I'll do router OSPF, and it says, what's your process ID? Could I make this 60,000? Yes, I could, and it would work just fine, but then I got to remember 60,000 every time I go and configure this router. No, just use one. So then I'm going to go in here and type in network 192.168.2.2.0.0.0.0 area 0. Hit the enter key. And network, oh, it happened so fast. 192.168.3.1 0.0.0.0 0.0.0.0 area 0. Did you see that message? See why these messages are so golden? You don't want to turn those off. It says, oh, OSPF adjacency change. That's what that ADJ change means. Process ID 1. We just saw neighbor 192.168.2.1. That's our friend. That's router 1 over there. On serial 0 just went from loading to full. Later on, you'll actually learn about all of the phases that a neighbor goes through. Initially, you go through an init phase, then you go through a two-way phase, then you go through xstart, exchange, loading, full. You go through all these different phases of neighbor, but it only reports the big one, meaning I now have a full neighbor relationship. How do we verify that? Let's go back and do a show IP OSPF neighbors. I would say that's your number one troubleshooting command right there for OSPF. And I can see right there on the screen it says 192.168.2.1 is at a full neighbor state. We're now fully exchanging routes between them. So how do I prove that this is working to me? Okay, I do show IP route. And this is from router 2's perspective. And I can see my two connected interfaces and OSPF has done its deal. 192.168.1.1 or 1.0 network. It now knows about. OSPF has advertised that to us. I can see now. What's all this other stuff? This, the 110, represents the administrative distance. Remember from the last nugget, the believability of OSPF. How believable is that route to me? I can see 74. That's the actual metric. That's the cost. How much does it cost me to get there? Now, how was that figured out? Well, it was based on the interface bandwidth I'll put in megabits per second divided by 100. Now I'm trying to figure out how it ended up getting to 74, but essentially just doing the math. Whatever this bandwidth is set to for that WAN link, I think it's 2 megabits per second, and then this bandwidth is set to for that WAN link. I don't know what it is, but it puts it into this formula, totals them up and says, okay, that is actually equal to the cost, which is the metric of OSPF. So it cost me 74 to get there. Where did I learn about it? 192.168.2.1. How long have I known about this route? 59 seconds. What interface do I go out of to reach that route? Serial 0/0. So now, of course, the ultimate test is always to ping it, 192.168.1.1, and success. We are there. Let's shoot over to router 1 because it should be feeling the same way. Notice, without typing anything, it gave us that status message. We have a new neighbor. Show IP OSPF neighbor. Verified the neighbor is there. Show IP route. And I can see I've learned about the 192.168.3.0 network. Got to ping it just to feel good about ourselves. And there it is. We're pinging it. We're successful. This is the neighbor that we learned it from. OSPF is in action. Okay, only other troubleshooting commands like verify. How else can we see this is working? I can do a show IP protocols. Show IP protocols shows us what routing protocols are running on our router. And I can see OSPF process 1 is running. I can see it's advertising or routing for the networks 1 and 2. And it shows the network commands that I've typed in. It says here are the interfaces that are configured as passive. That's kind of cool. It's even showing us that. Notice serial 0/0 is the only one not in that list. And then down here I see the sources. This is some neighbors. These are some friends that I've learned about. Last update was 3 minutes ago because now they're sitting there nice and idle. What are they doing? I mean, if I were to do a debug IP OSPF, what do we got here? Let's do packet. All I would see there is hello messages. Now you might say, well, how did you know that's a hello message? Because I know that's all I should see. You can actually go and break down each one of these fields, and they mean something. To where you can see this is OSPF version 2. This packet is type 1. It just so happens that type 1 is a hello packet. There's all kinds of different types of packets that are out there. What is the length of the packet? What is the router ID? Essentially, what is my name or the name of the router that's sending this packet? What is the authentication ID? I mean, you can actually configure authentication. It's really easy to make sure that. What am I doing? Did I just say authentic? No, I just made that up. Area ID. I don't know why I was thinking authentication. Area ID. It actually puts it in IP address format. This is area 0. You see a little checksum on there. That's what I was saying. This is the authentication. What kind of authentication are you using? OSPF supports clear text, not very good, and MD5 hashing, very good. Authentication between the different devices, and then what interface it came in on. Now I'm seeing these. It's like, notice they're coming in every so often. I can do a show IP OSPF interface and say, well, show me, for instance, serial 0/0. And I can see, serial 0 is a point-to-point interface. That's the kind it is. And I'm saying hello every 10 seconds on there. Somebody is going to be considered dead if they don't speak for 40 seconds. And do you get that feel about how often these little packets are showing up? It's about once every 10 seconds. There it is. There it is. So some key show commands that you can use to really see, kind of dig a little bit more of what's going on. Essentially, watch the magic happen, but understand a little more of how the magic is working. Can you believe that I thought I could fit all that into one nugget? Yeah, crazy, right? So let me just wrap this all up because I want to give you the big picture perspective. I don't know how long this nugget is because I'm still talking, but it probably is. I'm guessing about 30 minutes long or so that we've been talking about this now. But I want you to notice all of this boiled down to really 2 commands, right? Router, OSPF, and we did the process ID 1, right? And then network, and then we typed in the network, the wildcard mask, and the area ID, and that was it. And now I threw in the passive interface and some show commands for fun, but really 30 minutes boiled down to 2 commands. Now I know you're like, that wasn't efficient. we could have done that in 5 minutes. Well, the point is, there's a ton of configurations in Cisco that are 2 minutes long, but it takes hours of understanding the concepts of what you're doing behind there. The thing I'm trying to convey right now is make sure that sometimes it's so easy to get caught up in, I've got to remember syntax, I got to remember these commands. And yes, you do have to remember commands to type in, but remember that the commands are the easy part. Anybody can go on Google and type in, give me example OSPF configurations, and be like, oh, well, there it is. I can type that in and it starts working. But to really understand it, that's the key. That's what Cisco wants at the CCNA level, is that understanding of what is that network command doing? What what are those two things that it impacts when you go under the network command? So between this nugget and the last, we have seen what routing protocols are all about, the jelly bean jar of protocol choices, all the different flavors and features that are out there. And then finally, this nugget, we looked at OSPF concepts and configuration. I hope this has been informative for you, and I'd like to thank you for viewing.